right. Next up is our Energy from Waste team, which is Andreas Saltos, Aries Loomis, Arun Kutun, Ian Hamilton, Milos Otz, and Nikhil Bharadwaj. I think you guys. There's that, and I think you're on your own for loading things.
I got it. I don't.
Great. It's not.
How do I do it? I have to drag it over.
Tim?
Do I just drag it over?
I don't know. I thought they were mirrored. How do we get their presentation on the projector?
There we go.
Yes. Oh, there we go.
Cool.
Welcome, everybody. My name is Milos. This is my lovely teammate, Aries. And we and the rest of our team are going to introduce you to our company today. So I'd like to start by telling you that we believe in sustainability. We also believe in nuclear energy, and that these two concepts together are going to go on to change the world. We believe that with proper resource management, nuclear energy can provide electricity for filling global demand the world over. But in order to do that, we need to obtain electricity from every source possible, and we've incorporated that mantra into our company and into our product. I'd like to now paint a little picture for you to give you a sense of the application of our product. You are the operator of a nuclear facility of any type. But the lights are out, the instrumentation is dark, and off-site power and backup grid are gone. However, to your side, you have a lit screen that's telling you the temperature, pressure, and radiation monitoring of critical systems in your plant. And to your right, you have a secure line of communication to personnel around your facility. Events outside of design bases can and do happen with all technologies, and when they do, a source of power can be the difference between an accident and a severe disaster. We provide that difference. We are Auzel Technologies, and we generate electricity from radioactive waste. Our electricity can be used to power instrumentation that provides operators with key information, allowing them to make better decisions on bad days. And on good days, we save plants electricity costs on parasitic load, allowing them to increase their profits. I'd like to give you a little case study and provide some numbers to show an example of this. So to start, we're going to focus on the La Hague facility in France. It's a reprocessing plant that takes spent nuclear fuel and pulls out the uranium and plutonium, generating vitrified waste. We're going to focus on this vitrified waste, which contains fission products and minor actinides encased in glass. This stuff is hot. And the way it's stored is stacked in these steel canisters here. Our product is going to be on the outside of the natural convection cooling channels that keep these things cool. And what it does is it accepts the infrared radiation emitted as heat and turns that into electricity. The same way a solar panel does that for sunlight, we do it for infrared. The way we can do this is that we, in our product, have a thin layer of upconverter nanocrystals that take the wide spectrum of infrared light and compress it and funnel it into one energy that's accepted by the photovoltaic. Assuming a published result of 22% efficiency for this product, we estimate that La Hague is sitting on 11 megawatts of electricity in their current inventory of waste. We want to tap into that. We estimate that they're not going to want us in there. So we plan to we are going to design this product so that they install it completely themselves. We won't even come near the stuff. We're going to sell them the product, and they're going to put it in. We're going to sell it to them at a cost of $200 per square meter. That's $7 million for France to cover all of their waste channels with this stuff. And we're also going to sell them the electricity it generates at 6.5 cents per kilowatt hour, and that's relative to 9 cents per kilowatt hour generated in the current French grid. After 6.7 years, our company breaks even. After 10.3 years, La Hague breaks even, and they start saving money because of our product. After 15 years, our assumed lifetime of our product, we've generated about $35 million in revenue, and that's for this one facility. The core competencies of our product is that it is a unique product made by a unique team to fit a unique demand. Our competition is either too expensive, does not meet the design criteria, or is not focused on nuclear application at all. Some risks and mitigation going forward. Looking forward at challenges, certainly the research and development of this product will be critical. In addition, we've probably faced some high licensing and export control costs, and the installation is going to be difficult engineering. However, the demonstration of this technology will be easy. These are cheap, non-nuclear experiments, heat transfer experiments that can be done in a rudimentary facility. Looking forward, we are looking to partner with a strategic partner to help get our business, to grow our journey together. We're looking for $2 million for the first 2 years of startup costs. Of this, $250,000 will immediately go to the pre-application licensing process so that we can start to get that hurdle out of the way. We estimate $1 million for research, development, and prototyping, and the rest to cover business expenses, including salaries and benefits. Looking forward, we see a bright future for our product. Nuclear energy is growing, the inventories of waste are growing, and we see an opportunity for us to do something about it. We expect that we can make a dry cask version to open up the US interim storage market, and we could probably partner with DOE to tackle their massive reserves of waste at Hanford and Savannah River. As advanced reactors come online, we could partner with them to bring them on-site power for their fission product waste. Based on current nuclear waste reserves, we see a potential market cap of over $1 billion if you extrapolate this La Hague result. And as a company, we feel very passionate about the fact that we are enabling safety, promoting innovation in the fuel cycle, and demonstrating sustainability. We are Auzel Technologies, and with that, I would like to invite any questions, suggestions, advice, anything you might have to offer. Thank you so much for your time.
Fantastic. That was a really great presentation. I think you identified early on that you mentioned that some of the regulatory risks would be some of your biggest concerns. Could you elaborate on that a little?
So in our economic analysis, we actually accounted for $25 million worth of licensing. So that has been taken into account in our economic models. Does that answer your question?
Not exactly. Could you identify what it is that $25 million is going to go towards?
So the $25 million would go towards licensing, and due to the fact that we are generating not nearly as much as a nuclear reactor, licensing fees have been estimated to be at that cost. Our product is non-invasive and very easy to install, and doesn't involve with any of the current heat transfer issues regulated with the product.
So certainly we need to identify key issues of safety. Our product would not affect heat transfer, and it wouldn't add any moderators or reflectors that could affect potential criticality in this waste. That $25 million would primarily go, especially that $250,000 up front, would go to lawyers to make sure, to start the conversations, that pre-application process that's so critical in reactor markets. And we estimate that that's actually a conservative thing because our product is non-safety related. It's backup power. This stuff isn't turning on pumps. It's generating information for operators on bad days.
So is this something that you would intend to use only when power goes out, or would it be something that would constantly provide usable electricity for the operator?
Yeah, so the plan for, I guess, our device is on a normal day, we are providing cheap, clean power that can be used by the plant to basically reduce their load from the grid. And then in times of emergency, it provides an essential service in just being able to provide any information that can extend emergency response.
So if this is as good as it sounds, why hasn't anybody done it before?
People have actually looked at this. They've been developing these nanoparticles and upconverters for quite a while, actually since like the 60s. No one has really looked at the amount of heat or the spectrum that's coming off of these spent waste. And so we specifically actually contacted a supplier and worked with what type of nanoparticles we would need and how we could get electricity off of these essentially giant radiating black bodies. So we're not the first ones to think of getting waste heat, but we seem to be some of the first to look at applying it to these storage canisters.
And there are other companies that are interested in harnessing the energy from waste heat. But the thing is that they have shied very heavily away from the nuclear industry. And what makes us unique is that we're very comfortable with the nuclear industry, and that we are able to implement our technology because we know the licensing through this boot camp. We know more than any of our other competitors at this moment.
So you're a tiny U.S. startup. How do you break into the French market?
One of the reasons behind our licensing process is supposed to be taking into account export controls, and another thing is that we're incorporating patents. As we were advised from one of the speakers at this boot camp, that when you have a patent, it allows for greater freedom in the international market, as long as we are currently licensed with the NRC.
You're right, we're a small startup, but we can talk. Arriva's here, we can call them up.
Thank you.
Put them up on my cell phone.
I saw that. I saw you guys taking the microphone as far away from me as possible. I saw that.